Hi, you are welcome to GMats class. This is another question under variation, partial variation. Now look at the question. X is partly constant and partly varies with B. When B is 3, A is 7, and when B is 6, A is 9. Now find the law of variation. B, find A when B is 4. Now the question says that A is partly constant. So that is A equals to a particular constant. Let's label it P. A is partly constant and plus, and means plus, and partly varies with B, and partly varies with B. So this is B. So there should be a constant beside the variable. So we can call that Q. So we now call P, Q are what? Are constants. They are constants. So that's the first sentence we have here. Now the next thing now is to get a pair of equations. Now let's look at the first variable given. Now we are told that B is 3, A is 7. So we substitute inside this equation. B is 3, A is 7. So we have 7 equals to P plus B is 3. That's 3Q. So we call this one equation 1. Also, we are told that B is 6, A is 9. We substitute inside this equation again. A is what? 9. We have 9 equals to P plus B is what? 6. That's 6Q. 6Q. Equation 2. Now we now have two equations together. So we solve these equations simultaneously. So we can subtract equation 1 from 2. So we say subtract equation 1 from equation 2. So we have 9 minus 7. That gives us 2. P minus P, that is 0. Now 6Q minus 3Q, that gives us 3Q. So we have 3Q. And then, now to get your Q, you divide both sides by 3, the coefficient of Q. So we have 2 over 3 equals to Q. Or we say Q equals to 2 over 3. Now this is the first constant. Now we get the second constant. So we can move to equation 1. From equation 1, look at equation 1. So I'm writing it, but I'm changing the value, I'm changing Q to 2 over 3. So I have 7 equals to P plus 3 times Q. Q is what? 2 over 3. Alright? So we have 7 is equals to P plus, now this we cancel this. So we are left with 2. So 7 equals to P plus 2. So we make P to be the solid of the formula. So we have P equals to 7 minus 2. 7 minus 2. When you move this one here, the sign changes. So we have P equals to 5. So now we have gotten the two constants. So we have Q and we have P. So we come back here to get the law of variation. So we have, I'm writing this one out here now. So A equals to P. What is P? P is 5. Plus B and B times Q. What is my Q? Q is 2 over 3. So that's going to be 2B over 3. Okay, so that's what I'm going to have. Now is the law Law of variation. Hope you can see that. The law of variation, if you want to get the law of variation, you come here, you substitute the value of your constants. And that's what we have done. P is 5, we have it here. And Q is 2 over 3. I cannot put 2 over 3 at the back of B. It should be at the front. Okay? So, because if I put it at the back, it will not make sense. It's just like if I have X2. What is X2? No sense in it. But if I write it as 2X, okay, there is sense in it. Just like I say oranges 2. No meaning. But if I say 2 oranges, you can see there is sense in that. So that is one reason why your number must always be at the front of alphabet. Alright, so now this is the law of variation. Now let's do the B part of the question. Find A when B is 4. Find A when B is 4. So when B is 4, when B equals to 4. So we substitute inside the law of variation. We substitute here. We have A equals to 5 plus 2 open bracket 4 over 3. So A equals to 5 plus 8 over 3. Okay, 2 times 4 is 8. So A equals to, now what's the LCM? 3. 1 goes in 3, that's 3. 3 times 5 is 15. Plus 3 goes in 3, 1. 1 times 8 is 8. So we have A to be equals to, so you add this and this together. So that gives you what? 23 over 3. Okay, so you can now simplify. So 3 goes in 23, that's 7. 7, it remains 2 over 3. Okay, so this is the answer to the question. So when B is 4, A is 7 one number, 2 over 3. Now, I want you to try this for me. Find B when A is 3. Find B when A is 3. Let me have the answer. It's very easy. All you just need to do, go to your connecting formula or your law of variation, you substitute and you get the answer. I want you to drop the answer to this question on the platform. Thank you.